What's up again, everybody? Welcome back to the shop for another installment of MRO Mondays. I'm actually testing out the motion tracking app in my DJI handheld gimbal thing. So I'm hoping that's not, wow, that's a lot of camera motion. That might be kind of annoying. We'll try it out for right now though. Okay, so what we're going to be doing today is installing a coolant filter for the lathes. Oh, can I do this? Yeah, check that out. There's a lathe right here. And there's one over here too. And so basically I've been having an issue with very small chips going through the coolant lines and getting stuck in our through coolant tools, which is bad because you want coolant to go through them. You don't want them to be all plugged up. So what I'm talking about is we actually use a number of different tools. So we're going to sneak up on this thing here. So this is a fancy carbide drill, and you can see it has two tiny holes right in the end of it, and those correspond to these two tiny holes in the back, and high pressure coolant actually flows through those holes and out the front, and it basically puts the coolant right at the tip of the drill where you need it, rather than just trying to kind of throw coolant at it and hoping for the best. These things work great. They last a long time, only if you have coolant flow. We also use through coolant on our turning tools, which is a little bit unusual. This is a Seco Jetstream tool holder. So there's a coolant line that gets plumbed in right here. And there's a tiny little orifice right on the top of this tool. And normally there's a gold colored carbide insert that goes in there, and basically same principle. The coolant comes out right on top of the cutting area, which is again where you need it, where the cutting is happening, to give you lubrication and also remove heat from the cutting. But again, if the system gets clogged up, no coolant coming out, and that's no good. So what we're going to do is install one of these Seco filters, and these things just use a replaceable fiber wound cartridge. This one I believe is 20 micron, and this is the same filter that I actually came from Haas on the mill, and same filter. So I just basically spec'd up a system on McMaster Car, which was relatively inexpensive. Now all I have to do is put it together. I already did the first machine, so I sort of know what I'm doing on this one. In any case, let's get to it. Alright, so I've got my filter here. Got the filter insert, don't really need that. Get rid of that. Alright, so the first thing we need to do is actually open this up and apply some lubricant to the O-ring that is in here, because all O-rings need to be lubricated in order to function properly. This includes flashlights and anything, any O-ring. Fortunately, I've forgotten to go get the silicone grease, so I'm going to go get that right now. And through the magic of editing, I am fully prepared to do this job. Alright, so this is actually a silicone O-ring lubricant. I mostly use nano oil on everything, including flashlights. This works great on O-rings. The main thing that you have to keep in mind is that you want your lubricant to be compatible with the type of O-ring you're using. Otherwise the O-ring can swell or break down or dissolve or whatever. Anyway, this silicone O-ring lubricant is good for general purpose nitrile or Buna N O-rings, like this black one on here. The majority of O-rings are made from that material. It's cheap and it works pretty well. You don't need a ton of lubricant on an O-ring. In fact, having too much can be a bad thing. I'm just kind of squeezing on a little bead, and then we'll just rub that all the way around the O-ring. So just wipe that around, and I guess I could go ahead and put the filter in here now, because I'm not really going to need to open this thing again. So let's grab that. Ta-da! So again, this is basically a metal core, and you can't really see that very well, but it's just wrapped with some kind of fiber. if I was smart, like John Saunders, I would probably put pressure gauges on this. And I was actually wondering if these two little nubs here were actually designed for drilling and tapping. There's not a lot of meat in there, but Seco does have a model of this filter that's already threaded for pressure gauges, so I was assuming they just skipped a step here and that you could drill and tap pressure gauges on there. And what a pressure gauge would let you do is you put one on the inlet and one on the outlet. They should read the same thing. As the filter starts to get clogged, that outlet pressure is going to drop. I was hoping that would just be easy to observe when you're running the machine, in terms of you're just going to have less coolant pressure. I may regret that later. So this just slides in, and then this locking collar gets screwed on. I think I do want it on this side. This doesn't need to be really tight. Just kind of hand tight is plenty. I made one real dummy move on the last filter that I installed, and this is basically just a drain valve. And what I neglected to do was actually close the drain valve. I fired the machine up to test the coolant, and it just all poured out on the ground. So be sure that is closed and locked. All right, now I need my other goodies. Set that aside for now. Got some high pressure steel braided hose, some brassy stuff. This is a FIP fitting, which I can't remember what that stands for right now, but it's just, it's a flared pressure or something. Anyway, this is what's already on the machine, so I need an adapter for that. These are some giant magnets, which is actually how I'm going to hold the filter on the machine rather than drilling and tapping through the sheet metal. We're just going to put a couple big magnets on it, and it seems like so far that's working pretty good. Fingers crossed. That was a thumbs up. Fingers crossed. Okay, so I think this is basically everything I need. I'm just going to mock this up right now to make sure I've got all the right parts and I put them in the right place. This is I think a 1 inch to a 1/2 inch pipe reducer. Got to put in one of these on each side. I've got a couple elbows. One's female, and male. This other one is male and male. And let's see. This end, well, obviously this end's got to go in here. This is going to go to my outlet. So there's basically a manifold on the machine where the high pressure and standard pressure lines come in. And then let's see, all right, so that's going to come out. The male fitting is going to go in there. So I believe this should be the male to male side. Because this male fitting has to go into the manifold. This one's going to go on. Oh no, where's the O-ring? So as you can see with this one, there's a little O-ring attached with a rubber band. This O-ring is gone. That could be a problem. Alright, we'll figure that out later. That's going to go on this end. This is the return line that's actually going to deliver the coolant to the tools. It's going to go like here. Also, fittings. So normally the male end, you can't turn. It's basically attached to the hose. So in order to turn the fitting, you have to rotate the entire hose. The female fitting turns freely until you get it tight. So whenever you're plumbing a system like this, you really have to pay attention, because if you had male ends on both of these hoses, by the time you screw in the other end, there's no way for you to rotate this end without it getting all bound up. So you do need one male and one female end. You also have to pay attention to which end you install first. So obviously we have to install the fixed end first and then allow this end to rotate freely. So as you can see, I have to rotate the entire hose to get that to fit in there. Then on this end is going to be our pressure fitting. So I'm actually going to take this O-ring off, put that in there, and then again this is I think a 1/2 inch pipe thread. That's going to go in there. And then this is the pressure fitting that's actually going to attach to the line that's already in the machine that delivers the coolant. Alright, so this is looking good. The magnets that I used, I get generally buy my magnets from amazingmagnets.com, and amazing they are. These are cup magnets, so they're basically directional, so they're non-magnetic on this side and very magnetic on this side. I think each one of these two magnets holds something like 80 pounds, which is going to be plenty for us. I also got some rubber feet that slip over the magnets, and that is just to keep, basically if you put this on the painted sheet metal, this whole thing's going to slide around, especially if there's any vibration. So these little feet just slip over the magnets, like so. I wasn't sure if that was actually going to work, but based on the first one I installed, it seemed like it actually worked fine. So we've got those two magnets. Actually, these are these injection molded plastic washers that come with all the magnets, and they separate the magnets so they're not all stuck together when you get them. But they're pretty thick. I'm not totally sure what they're made of, but I actually generally keep these and just use them for other things. Alright, well, after an exhaustive search, that O-ring is in fact missing. O-ring, washer. It's made out of some weird material, so I don't know, I'll have to come up with a solution for that. In the meantime, this is the mounting bracket that comes with the filter. Now, on the website it did not say that it came with a mounting bracket. Fortunately it does. I actually bought some angle iron to make one. I don't have to do that. Alright, so I don't actually need these bolts because the magnets have a threaded post. I do need to go get some 1/4 inch nuts to put that on. This is actually just a little tightening handle, which honestly isn't really necessary, but I suppose over time it could get kind of gooey and sticky, and you just stick that pin in there and rotate it. Okay, and my bracket's going to mount this way. It's just going to mount on these two little holes, and then the magnets are going to go in here. Okay, we're back. I got 2/4 20 nuts in my little nut driver. I really should have got magnets with longer posts. I was just not thinking clearly. So there's not a lot of thread that comes out of the back. What I wanted to do is actually put a nylock nut on here, just to make sure if there's any vibration or whatever, these things don't back off. But honestly, it's not that big of a deal. Oh, do I have a 1/4 28 nut? That could be a problem. That one's 1/4 20. Alright, so that just goes on. No washer or anything, just because I don't have enough thread length. But again, this is not a really demanding application. It should be fine. I did size these two magnets. Fortunately, I did think about something when I bought them. So they would not touch each other when mounted on the bracket. Alright, this is my last 1/4 20 nut that's not a nylock, so time to hit the hardware store. Screw that down tight! Alright, should be good. And it's going to mount there. So I do need that hardware set aside. Again, just another 1/4 20 nut with a lock washer. Word is on the street that lock washers with this little split, it's supposed to lock the bolt. It actually doesn't. I don't even know why they make these things, but at least it makes a good normal washer. Basically the idea is this little edge will dig into the bolt and keep it from rotating backwards, but when you have it fully clamped, that edge isn't sticking up. So what's the point? I don't know. Just get that started. Another thing, general fabrication tip, is you never want to tighten anything until you've got all your screws in, because once you tighten one screw, then that position's fixed and things can be more sticky. This is hard to do, so you guys can see what I'm doing. I'm always in my way. Alright, again, snug that down. All right, that's the dilly. All I got to do is figure out what I'm going to do about this missing washer, and then get this bad boy installed, which unfortunately behind the machine there's just not a lot of space, so it is a very cramped and sweaty and otherwise unenjoyable process. Lots of grease, slime. Anyway, that'll be the next part. All right, we are back at it again. Late night in the shop. I did not get the install finished before, so I got to come in here at night when there's nobody working and the machines aren't being used. So we got the filter sort of mock-up assembled. Now, basically, I need to do a more permanent assembly and then get this bad boy installed on the machine. So right now all these joints are loose. I got to take all this stuff apart. And then these are pipe threads, but I do like to seal them anyway, especially in a high pressure application or something that's hard to access. I want to be really sure we aren't going to have any leaks. Normally, people use Teflon tape. I often use Teflon tape. It works pretty well. However, I do find it's a little bit unreliable. It's kind of hard to know exactly how much tape to put on, and if you don't get enough, then you're going to have leaks and stuff like that. One nice thing about Teflon tape, it's relatively easy to remove the fittings at a later date. However, I like to make my life easy and hard at the same time. So I'm going to be using, well, that's not going to focus, pipe threading compound. Oh, there we go. It's sort of focused. Pipe thread compound. And it's this kind of watery, kind of syrupy silver goo. You just put it on the threads kind of like paint. And then basically, after it dries for a little while, it's all set up and the joint's tight and it's going to be waterproof. You don't want to put on too much because it's just going to squeeze out of the threads, but again, you've got to get enough on that you actually have a seal. The difficult thing about this is that if you want to take it apart later, it's actually quite difficult. It gets pretty sticky and it's hard to remove. So hopefully if I do everything correctly, I won't really have to remove it again. So we're going to proceed under that assumption and get this thing put together. Sound good? All right, I guess cue the fast forward assembly montage. Hit it. I am being careful not to get any of the pipe compound on the inside of the fitting. It just seems like it would be a bad idea for this stuff to get pushed through the coolant system and clog it up somewhere. Oh, it's going to be tight. Very tight. Oh, but it's okay. Oh. All right, that should do it. So you can see on these joints there's a little bit of pipe compound coming out around it, and I believe that is what you want. Again, you want to have the right amount, not too much. So you can kind of see right here. I feel like that's going to be good. Now, alright, so if you remember, the female end rotates, the male end does not. So basically I need to install this end on the machine first and then attach this end. This is the other end with the FIP fitting. And if you remember, I am missing a washer. It's basically just a flat seal. I can't really tell what it's made of, but it's some kind of really hard rubber. When I came in here tonight to do this, I actually completely forgot that I am missing one of these. So basically, I'm going to take a piece of Teflon, and I don't have to make my own washer. I don't have a lot of plastics in the shop. I'd actually rather do this out of nylon, which is a little softer. I feel like Delrin's too hard. But I'm using the Teflon because it is a little bit squishy, and then I'm hoping once we can press it in there, that's actually going to make an okay seal. No idea if this is going to work or not. But I, again, was not planning on taking the time to do this. But over to the lathe. All right, I'm going to pull some dimensions off of this thing. OD. Oh, yeah, you're not going to be able to see that. OD. ID, and then thickness. Let's call that 730. Oh, and just for reference, this is the washer that I do have. And thickness is going to be about a 16th, 630. Alright, that should be all I need to get started. I'll try not to lose this guy, because that would be smart. And again, Teflon, no clue if this is going to work. So if anybody thinks this is a bad idea, you should tell me now. Teflon, yes, no? Anybody? No? Alright, let's do it. Careful on the cut through, just so I get a... This lighting is awful, just so I get a smaller burr on the inside. It seems like a reasonable approximation. And on the camera, it's so blown out, it almost looks like it's the same material. Alright, let's go finish our assembly. Alright, we're back. So here's the deal. I'm actually going to put the original washer on this fitting, because this is going to be a little bit deeper in the machine. This hose is going to connect here. And this is actually relatively close to where I'm going to want to install this and access it from the outside. So if I do have a problem with this washer, this is going to be the easiest part to get to. And because this presumably is a seal, I don't need to put the thread compound on these threads, as far as I know. Alright, that feels appropriately tight. Now all I have to do is not lose my Teflon. So this is the little deburring tool. It's kind of a bladed hook. I'm just going to stick that in there and run her around the edge. It's a little hard because the part is small. Cool. Looks like that'll work. At least until we run 300 pounds of machine tool coolant through it. Alright, now we're on to the really unpleasant, sweaty part, so let's do that. Alright, let's take a little walk. Oh wow. Alright, that thing's too heavy to hold up for that one. Okay. Alright, so we're behind the lathe. This is where the magic is going to happen. So, I got to squeeze in here with myself and all my tools. We're going to have a couple of beta QRs on flex arms lighting up our work area. And I have to, well, you can't really see anything. There's a lot of grease and dried coolant and stuff like that back there, which I am going to have to address. How about some light? Anybody would like light? Yeah. Look at that. Okay, so basically, yeah, light. This black thing right here is the manifold where the low pressure and the high pressure coolant lines go in. This is the high pressure exit. So I'm actually going to drop this manifold out, remove this plug on this end, switch it over to that end, and then I'm going to mount the filter with the magnets right on the wall here. The hoses are going to run around behind this pump and get plumbed in. So this is going to be the outlet. It's going to go to the filter. Then the return line from the filter is going to get attached to this silver pressure fitting here. Alright, let's get to it. I'm not quite sure how I'm going to film this. I imagine anywhere I put the camera, I'm just going to be completely in the way, so we'll do our best. Alright, well, that is about as good of an angle as I can get while still having room to work. So there you go. Alright, the first thing I got to do is do a little cleanup. There's a lot of grease and dried coolant sprayed around in here. And I don't need to get a ton of it on me, so. It's never bad to clean up a little, right? Alright, so this line, I'm gonna cut the zip tie off here. Oh, come on. Without cutting the hose, hopefully. Alright, yeah, so this line here is the coolant skimmer. Alright, so I do have to get this end plug off over here, so I'm gonna try to do that while it's still. Oh, I'm totally not gonna have room for this. Oh, maybe. So I just wanted to get this out while it's still rigidly attached, which makes it a lot easier on me. The real thing I want to avoid in this entire process is dropping any of the parts into the coolant tank, because that would be a bit of a problem. Okay. Oh, that was close. I almost dropped it. Oh, you know what? I done forgot another tool. I do have this tool though. It's a 90-degree air screwdriver. I don't think it's gonna have enough torque to break these screws loose, but we'll give it a whirl. Just make sure I go rotate the right direction. Gonna have to pop this fitting off. I really don't like to break seals if I don't have to, but this thing's just too much in the way. Oh, really? No, that's alright. So, yeah, this thing's attached with a band clamp. This is supposed to rotate freely, but it's bound up a little bit. Hopefully that's not going to be an issue. Nope. More money and more tools. That's always the solution to every problem, right? Do this the old-fashioned way. I'm just gonna try to break these loose and go back to the air driver. Alright. That is loosening. Okay. Oh yeah. Don't drop it, don't drop it, don't drop it. Don't drop it. Oh, okay. One down. Yield extension. Oh, down she comes. Alright. Come on out. Alright, now I gotta get both of these things off and then install the plug in this end. Oh, alright, so now I'm running into the problem where this fitting, female fitting, is tight and it's wanting to rotate the hose, so I'm actually going to have to break this loose before I remove this other one. Obviously. Oh, yeah. Alright. Yes, now this whole thing will come right off. Also try not to damage the threads. Go ahead. Still need a wrench. Okay. So this guy I should not need anymore. Alright, all the red stuff on here. Some fasteners and fittings you can get with thread lock already applied, which is what the red stuff is. It does look like there's some other white stuff that is some kind of pipe compound that was actually not on the other machine. And again, I'm just trying to get the thread locker out because I don't really want the machine to adjust that. Alright, so the plug I pulled out from the other side, I got away with this. On the other one, there's still, you can see the red stuff on there, there's still quite a bit of thread sealant already applied to it, so I'm just gonna go for it. And you can kind of feel it gets tight because of the sealant. I think this is going to be fine, but I am going to go ahead and screw it in pretty far. Okay, that's probably good enough. This is going to be the outlet, which needs to go to the inlet. So I've got that male end. This is the end where I made the Teflon washer, which I have not lost yet, although I'm doing my best. Back to the pipe compound. Again, I'm trying to get just the right amount, whatever that is. So, put that in here and make sure that is the right thing to do at this time. Now again, this is kind of a hassle because I have to rotate the entire hose to get this thing in here. Alright, hope that's good. So I got a little excess I'm going to wipe off. I think I'm ready to reinstall this guy, which is my least favorite part, because the whole screw dropping thing. Alright, we got that bad boy in there too. Righty tighty. That's something. Yes. Alright, let's go ahead and reattach this guy. That should do it. Okay, so right here is where we're going to mount the filter. I am going to try to clean this surface pretty well because my magnets are covered in rubber and I don't want this thing sliding around when the machine's vibrating. And magnet. Alright, so this is the outlet hose, which is going to get plumbed back into the FIP fitting. This guy is going to go attached there, but I will need my Teflon doodad. Oh, well, on the plus side, this machine does not have a Y-axis, so there's actually a lot less machine sticking out here that'll potentially run into the filter when the Z travels all the way towards the chuck. I had to be pretty careful with this area mounting the other filter so it didn't hit that. Alright, I don't exactly remember. I'm pretty sure I tightened these fittings, as I'm sure the video will show, but just in case. Okay, good. Tight. Tight like a tiger. Alright, so then since this side's got the female fitting that rotates. That should be no problem. Okay. Das ist gut. Look what I've got. Now I have this oil skimmer return line to deal with. Okay, return line is actually a little shorter than I'd like it to be. Close, but cigar. I think we're good. Yeah? Tightened everything, plumbed everything. Now all that's left to do, hey, how are you guys doing? Is clean up all the coolant I just spilled on the floor. Fire up the machine and see where it sprays out. Yeah. This is not my happy face. So the word of the day is Murphy. I was actually not expecting to have any problems because I didn't have any problems with the other installation, but I have actually 2 leaks, which is a huge bummer. One of them is on one of the pipe fittings from the outlet, and the perhaps bigger problem is the actual filter cartridge housing is leaking around the big O-ring where that silver part slides up. I took it out, cleaned it off. There were actually some chips on the O-ring, which is not great. And if there are any chips that get in between there, it's going to leak. So I cleaned it off, re-lubricated it, put it back in, and it is still leaking. So I don't know if I'm going to be able to fix that or not. I don't know if like the groove is cut too deep. Anyway, I'm going to try it again. On the other pipe fitting, I'm actually going to go with the Teflon tape this time because that pipe compound actually takes some time to set. And so, you know, I don't want to be here for another hour. It's like 10:30 already. So I'm just going to put Teflon on it and hope that works. Then I don't have to wait for it. And then I'll try to figure out the housing problem. But if that O-ring groove is out of spec, there's not much I can do about that, which is going to be a problem tomorrow when Gilbert gets here and wants to run the machine at 7 a.m. So hopefully I'll have better news.